Welcome to the GeoMethod channel. Today we are solving another interesting geometry problem. Here is today's challenge. Can you find area of the green square? Take a moment to study the figure. Then let us uncover the key geometric ideas that make the solution click. A green square sits snugly inside a red rectangle, whose area is 684 square units. Our whole job is to find the area of that green square. Call the side of the green square S. Because a square's area is side times side, its area is S squared. So if we can pin down S, the answer follows at once. Notice the green square reaches from the right edge all the way across to the left edge. That means its side S exactly equals the rectangle's width H, a fact we'll lean on for the area. The rectangle's area is its length L times its width, and we saw the width is S. So L times S equals 684, an equation we'll come back to once we know L. Above the green square, there is a thin white strip. Call its width A, the top margin between the rectangle's edge and the square. On the other side of the square, there is a second white strip. Call its width B, the bottom margin between the square and the rectangle's bottom edge. The right mark of 33 runs from the top edge of the rectangle down to the bottom side of the square. That span covers the top margin A and then the square S, so A plus S equals 33. The left mark of 22 runs from the top side of the square down to the bottom edge of the rectangle. That span covers the square S and then the bottom margin B, so S plus B equals 22. Take the right mark's equation and subtract S from both sides. The top margin, A equals 33 minus S, written purely in terms of the unknown side. Do the same to the left mark's equation and subtract S. The bottom margin, B, equals 22 minus S, again in terms of S alone. Reading the rectangle top to bottom, its full length is the top margin, then the square, then the bottom margin. So L equals A plus S plus B. Now swap in our two expressions for the margins. The length becomes 33 minus S plus 22 minus S. Aha! The spans 33 and 22 cover the rectangle once, but they cover the square twice. So their sum is rectangle length plus square side. L plus S equals 55, or L equals 55 minus S. Return to the area rule. Length times width equals 684, and replace the length by 55 minus S. Now everything is in the single unknown S. Distribute the S across the bracket. 55S minus S squared equals 684, which is a quadratic hiding in plain sight. Bring every term to one side so the quadratic reads S squared minus 55S plus 684 equals 0. That is the clean form we can solve. Use the quadratic formula. Its discriminant is 55 squared minus 4 times 684, and its sine and square root decide the roots. 55 squared is 3025, and 4 times 684 is 2736. Subtracting gives a discriminant of 289. 289 is a perfect square, 17 times 17, so the square root is exactly 17, which promises whole number sides. The quadratic formula gives S equal to 55 plus or minus 17 all over 2. That produces two candidates, 36 and 19. Aha! The quadratic offers 36, but the diagram vetoes it immediately. The bottom margin would be negative 14. Geometry selects the valid root before any final area calculation. So the side must be 19. That leaves a top margin of 14 and a bottom margin of 3, both positive, so the figure holds together. The length is 55 minus s, which is 55 minus 19, giving 36. Width is 19, so we now know both rectangle dimensions. Finally, the green square area is s squared, 19 squared, which is 361 square units. So the answer is 361. That completes the solution. A good geometry problem often has more than one beautiful solution. If you see a genuinely different construction, a high-level idea that leads to another solution, or a thoughtful adaptation of an existing method, share it in the comments. Even a rough idea is welcome. A sketch of the key move is enough. We greatly appreciate these contributions. With your permission, we may feature the approach in a future Viewer Solutions episode and acknowledge you by name or channel handle. Thanks for exploring geometry with GeoMethod.